This conference will now be recorded.
Cannot hear you.
Hello, hello.
Yeah, Gopi, I can hear you now. You can
Yes,
hear
yes.
me?
Yeah.
Okay, okay. Let's start then. Okay. So the architecture. Okay, we already had a brief discussion on this. Okay. Okay. So I'm just starting the architecture summary. I'm just muting everybody. Okay. So okay. So as you can see over here, this diagram, there's a process known as the post master process, shared memory. Okay, and then there are some background processes, and there are some on the blue color. They are files which are on the disk. Okay, the green color are the background processes, and the post master process which act as a supervisor. So this memory and this postmaster, the shared memory, and these processes are all on the primary area of your operating system of your machine. These are all the primary area of your operating system: postmaster, shared memory, and all these green colored processes, right? All these are the primary area, and this blue color are the uh, data files, or the files, you can say, are the files on the disk storage. Okay, so these are the files, storage files. Okay, so we'll go through all this. So postmaster, now postmaster is a process which is act as a listener as well, which act as a listener. So any new session coming in, it will first connect to the postmaster. It first connects to the postmaster. Postmaster runs on a particular port number, by default 5432, but definitely while configuring you can anytime change it and then restart your cluster. So one postmaster for one cluster, for one cluster, database cluster. We'll talk about cluster as well. So postmaster or postmaster is the parent process of all the PostgreSQL server. So by executing pgctl utility with start option, a Postgres server starts up. It allocates some shared memory in the it allocates a memory area, a shared memory area in the memory, starts various background processes, starts a replication associated process and background worker process if necessary, and waits for any connection to come in. So whenever you start your database or your database cluster, this structure comes up. This structure comes up in the postmaster. Okay, this structure comes up in the shared memory, where this shared memory is there, postmaster is there, some processes are there, and some files are there on the disk. Okay, so how does it work? I think we already explained. I'm just coming back. How does it works? It works in this way that any request coming in, with any select statement coming in. Okay, so let's start with the select statement. Any select statement coming in, it will first go to the shared buffers. Now shared buffer is the memory area that is containing the data. Okay, that is containing data. So it goes to the shared buffer just like a select star from EMP. Not even data, all the metadata as well. Okay, so metadata is also contained in the shared. So all kind of data, every data is contained in the shared buffer. So metadata means the data about the data, which may contain where the table is, what is the location of the table, do the user have a permission to access that table or not. Everything would be contained in the shared buffers. So this shared buffer is getting the data from these data files, right? This is linked data file to shared buffer. Now this shared buffer is getting the data from the data. So assume a statement comes and select staff from a table, maybe school. So I say select staff from school. So it go to the shared buffers, checks if it does had a permission or a authority to check the EMP school table or not, where the school table is, which schema, or whatever it is, which row ID, which location. So everything will verify. Everything verify in the shared buffer itself. Okay, so if it does needs any information, if it does not have, it might get the data from data files as well. So shared buffer and data files are always linked to each other. Now I do a select star from EMP. I fetch the data EMP table from shared buffers, and I will return to the user. Simple. I return to the user. If EMP table is not there in the shared buffer, it will get it from the data file. Okay, it will get it from the data file. If it is there, it is great. If it is there, definitely performance would be better, right? If it is not there, it will go to the disk, do one more read from the disk, and get it on the shared buffer. But everything is written to.
The shared buffer is just like a cache, right?
Yes, cache is a cache. So this all is the complete shared memory is a cache. The shared memory itself is a cache. So the cache for all the tables and indexes or least recently used algorithm is followed. So maybe once it is full, it will age out all the previous data from the which is not being utilized. It will keep on aging it out as well.
Mhm.
Next comes the DML statement. Next
Mhm.
comes the DML statement. In case of DML statement, any change happens. So if any change happen, a entry, a logbook. Val buffer is kind of a logbook. Okay, val buffer is kind of a logbook where changes are being stored. So any update statement happen, what it will do?
No, yeah, any update statement happens, so the data is being written into the shared buffer, into the val buffer.
Right. Let me. Okay, so if any change happened, it will update the data in the shared buffer and will make a log entry in the val buffers. Okay,
Mm.
it will make an entry in the val buffers with the what we say with the primary key ID, with the old row and the new row. It's just like an entry of a logbook or the previous data and the news data. Just like any if you assume any school principal changes, any chief minister of any state changes, or maybe in US a governor is changing, maybe on the nameplate a new governor name is written, but there would be some logbook, right, which would be containing the old and the new. It's just like that. Now val buffer is being linked to the val segments. So now every commit occurs, this val buffer will flush the data to the val segments, because commit is something which is end of a transaction, which is make everything just like a control s when you do MS Word also saves. So in this commit is kind of, but commit by default occurs with every statement in Postgres. Okay, with every statement commit occurs, but uh, you can make a changes so that commit doesn't occurs after every statement. Okay, sometimes for performance reasons as well. Okay, we might make changes, but val buffers will write to the val segments at every commit. Just remember that. Okay, even though commit occurs after every statement by default. Okay, we know it or we doesn't know it, but if we configure our parameter in such a way, or in sometimes in procedures, in packages, in PL SQL blocks, commit does not occur. Okay, commit occurs only in small SQL statements. Otherwise, you have to type the commit explicitly in such blocks.
Mhm.
Okay, so this is the concept of shared buffers and val buffers. So data files and val segments. Now the concept comes of all other processes and other log files. Now other error log file is the log file which is containing all the log messages, warning messages, informational messages, that are major things happening to the database. Just assume I added a data file, okay, or I added a table space, not a data file, I added a table space, I create a user. So some major changes that are happening to the database, not the DML and DDL changes that will not go to the log files, but some major changes, internal errors or internal bugs, all such entry goes to the error log files that help me to troubleshoot.
Mhm.
Now comes the archive val. Archive val file is something, uh, archive val some val archive val is something which is kind of a copy of val segments. So how does it work? Val segment has some stipulated size, some defined size, just like 1 GB we defined in Postgres. So the size of each file is 16 MB. Okay, we give 1 GB to val segments folder. So when this 1 GB is full, this will start overwriting the first file. To not to save these files for future use, I copy this archive wire. I copy this first to the archive wall. So what is the benefit? The benefit is, these archive wall I rarely would be required. So I can put into a slower disk, I can put into a tape or something, or I may not need it also after some time. Because if I take the backup of the database, I need not to take this. Just assume I take a backup of my database on Sunday. Okay, and take a backup of Sunday. Now this backup I store in some tape in some location, and maybe I keep couple of copies. So I don't need any archive file before Sunday, because anything, if I want to go back on Sunday, if any crash happens, I have a Sunday backup, right? But assume my uh, my database crash, or my database crash happened on Wednesday, some corruption happened on the Wednesday. Okay, so I have a backup of Sunday. So what I will do, I will restore this backup. I will restore this backup, and I will, there's an internal mechanism for Postgres where you can apply those archive files from Sunday to Wednesday. Okay, maybe a crash happened at 10 o'clock and there is some loss of data at that time. So maybe to reduce that loss, I will recover and restore the backup of Sunday, and I will keep on applying these archives. So internally archive files can be applied, so it will keep on applying whatever changes are being made, as anyways it is stored into the archive, right? So this change the old data and the new data. Now these things will become useful when any crash happened, or when any corruption happened in the database. So I can restore till that time, whatever the archive or log files are available. So in this way it works. But if you take a backup, then for that time, that archives are not required, kind of. Okay, but assume I take a backup on Sunday. What is the date? Maybe 10th. Okay, and I take a backup on 5th, but I want to restore the database of 7th. Okay, maybe whatever I did in 3 4 days, that is all I don't require. Some nonsense happened in 3 4 days, and I want to go back on the date of 7th. Okay, what I will do, I will restore the backup of 5th, and I will apply the archive logs till 7th. A rare scenario. Definitely, this will doesn't occur in the database. Nobody will do such disasters for 4 5 days. Maybe for 5 10 minutes, I want to restore back or want to flashback back, but doesn't for such long time. Okay, I hope this archive is clear and this vals is clear. Error log files I covered. Background writer is the writer which
Yeah,
process
yeah.
writes from shared buffer to
What
database.
is the exact uses of val buffer? Why we are capturing all the changes data in val buffer? Is that something like what is the exact purpose of val buffer?
Val buffer purpose is backup recovery only. Its purpose is backup, recording the changes, and for backup recovery in case of any recover. We want to recover the database. So this val buffer is required. Assume you you want to keep a no logging database as well. You can keep non logging also. Okay, you want to uh, you can minimize the logging also, but but to some extent logging is required internally by the database, but you can minimize the logging as well. You don't want to that every statement should be logged in, then you can minimize the logging as well. Okay, that is also possible. And you can disable this archive val altogether as well. If you're not very much concerned about your about to recover your database is not production, you can rebuild your database anytime. You need not to have backup, or you just want to have a backup and you just don't want to apply the archive log files, or you're taking backup every day kind of, and you are okay with risking some hours of data. Okay, then this archive and val buffer is not required. Okay,
So all
you can feel.
incremental and all changes data are being recorded in a val buffer, right?
Yes, all incrementing, that is incrementing all the kind of a logbook, all the changes that. So you cannot take a backup every minute, right? You cannot
Yes.
take a backup every minute. So whenever you take a backup and you want to recover till that particular point, then it will automatically applies those changes to your data files. Okay,
Hmm.
it will automatically apply. There is a recovery process that will apply all the changes that are recording into the archive file to the data files. So concept of val buffers, val segment, and archive is only for the recovery. Just assume anything you are not logged into the val buffers, because there could be some statements where you can specify no logging, so that will not will go to the val buffers. Okay, so then what then if a crash happened, that data will never be applied back to the database. Okay, if it is taken during backup, it is fine. After backup, if any change happened to the database and you didn't logged the database in val buffers, okay, by default anything everything is logged, but you specify some parameter which will not log to the database, then in case of recovery, that data will be completely lost.
Lost.
Okay,
I see.
that okay, so that is the kind of
This is kind of
the
incremental
science.
backup. This is kind of incremental
Yes,
backup of all the changes data, DML in
yeah,
setup. Delete.
yes, you can say, you can give a term of incremental backup as well. Okay, so
Uh,
now comes the stats collector. Okay, we'll go through this theoretically as well. I'm just telling you on this slide as well. So the one comes the stats collector. Stats collector is a mechanism. So these principles of val buffers, val segment, archive val, stats collection, these are all common in every database. This is not a new technology this Postgres is giving you, right? So this is which is there in every RDBMS database. Whether you go with Oracle, you go with MS SQL, you go with Redshift, any data, any RDBMS, MySQL or anything. Okay, so this is the same technology. Might it give different names? Okay, might give val buffer can become a redo log buffer or transaction log files. So name can be different, but technology remains the same. Okay,
yeah, yeah. So,
okay.
so,
So stats,
so coming to the archived, what are the stands for WAL val? Is there an abbreviation?
write ahead log,
Oh, WL stands for right.
write ahead log.
Oh, upfront. Uh,
Yes.
I see.
Okay.
So you are
So
being backed up. You are being backed up of all the val segments into the archived val, right?
right.
Okay. Yeah, that's okay. Go ahead. Yeah.
Okay, so stats collector. Now, stats collector is something now regarding that stats collector. Um, so the database should know what where my table is, right? Where my table is, which block, which disk, where it is, and what is the size of my table. What is the cardinality of my table? How the where the indexes of my table and where. So all such kind of data about the data, which is known as a metadata. So all
Yes.
this metadata is being collected by the process, the stats collector process. Now the stats collector process collects the data and put it into some statistics tables or statistics dictionary table. Okay, statistics dictionary table in the data files itself. There are some statistics table, and this will put they will collect the data about data and put it into that dictionary tables. There would be pg stat activities, so all kind of statistics, just like all the sessions that are coming to database. What all sessions are there, what are the username, which host they are coming in. These are all statistics about your database, right? About the
Data
database as well, all these
demographics.
sessions.
Data
uh,
demographics about the data of the table. Yes.
Yes, about your database, about your sessions, about the instance. So all these statistics, which is because these statistics are changing every second. Okay,
Yes.
but this statistics collection will not happen every second. This will have some stipulated time, once in a day or after a few minutes. So we'll design all this. We'll set on these time as well when the statistics collection should happen. Okay, it should be manual as well. It can be manual. It can be automated as well. So all this can be, we can plan to do it. So this statistics collection generally goes a lot of times in a day, but we'll see. We'll see in the other later chapters how does it works. So this is stats collector, log writer, val writer, auto vacuum. Now auto vacuum is also is a process. There's a technology in Postgres that is known as I do not remember their name. Okay, we'll come back when we discuss further when this in that chapter of auto vacuum.
Vacuum delete
I'm just
and vacuum stuff.
telling the point.
It internally release the. It internally mark all the logically deleted rows
Let
into
me
the. Yes.
let me speak. I'm telling you. I'm telling you. Okay. So what happens in Postgres is that whenever you delete any row, okay, whenever you delete any row, It is not automatic, it is not deleted from the disk or not from the buffer also. Okay, not from the disk, actually it doesn't delete from the disk and doesn't delete from the buffer. It just mark that row is deleted, because at that time it doesn't have a time, or it just want to do it as soon as possible, so just mark the row as deleted. So now this auto vacuum process, and similarly for update statement, it's just update statement in Postgres is not an update, it doesn't updates, it inserts a new row actually. It marks the previous rows as deleted and inserts a new row. Okay, so these all junk rows gets keep on adding up in your tables, right? So all these junk rows, auto vacuum will go and clean up all these junk rows. Okay, it will go and clean up all these junk rows. So this is the functionality of auto vacuum. So now auto vacuum, is it works every minute. Okay, by default it runs every minute, sees which tables needs and vacuum to be done, so it gets executed every minute. Keep on running continuously in your database, keep on running, analyzing each and every table that is coming in, one by one, one by one, one by one, and we'll see whether it is needed. Wherever it is needed, we'll go ahead and clean up the data.
Mhm. Yeah.
Okay, so this is all about the processes of the Oracle, for the Postgres, sorry. So this is about the architecture, the high level architecture for all these files, the four major files, the 6 7 processes, and these two buffers, val buffers and shared buffer, and then there's a process array. So in addition to these buffers, okay, so now we discuss about this Postgres process. So whenever, let us go through the bullet points as well. Whenever receiving a connection request from a client, it starts a backend process. Okay, and then the started backend process handles all the queries issued by the connected clients. So what does it means is, whenever a request comes from the postmaster with any session, whenever somebody do PL SQL or through PG admin tool, or different ways to connect to Postgres, whenever it makes a connection, it starts a process for that. It starts a process for that particular connection. That process is known as a backend process. Okay, backend process are also known as a Postgres process as well. So
Mhm.
whenever till the time that session continues, that process will be there. That process will be there. It will bring that process, go to the shared buffer, do all the processing, give it back to the give
Custom.
back the data to the client, to the business, or whatever, say to a user, whatever it is. Okay, so this is the backend process. The postmaster starts a backend or a postmaster process. This is so backend process, which is also called a postmaster process, Postgres process, is started by the postmaster for each client request and handles all the queries issued by one client. It communicates with the client by a single TCP connection using semaphores and share memory, and terminates when the client gets disconnected. So whenever the clients get disconnected, the process automatically gets cleaned up.
Mhm.
As it is allowed to operate only on one database, you have to specify a database you want to explicitly authenticate it with username and passwords. So whenever you are making a connection, you have to provide the database name, username, and passwords. So whenever you make a new connection to any other database, a new process starts. Okay, it doesn't
Mhm.
it not utilize it will not utilize the existing process. A new process starts. So Postgres allow multiple clients to connect simultaneously. So the configuration parameter max connection controls the maximum number of clients. So at a time by default 100 connection can be made to particular cluster, but this is not a real-time scenario. A real-time, there are a lot of connection at a time to the database. You can increase. Generally for development and test, hundreds are good enough, but in production scenarios, the users are more, you can go up to thousands as well. Okay, I think there's no problem. Postgres can survive still a lot of connections, but definitely is not an web-based application. You might be, I am already told you, it's not a kind of very database which is good for web-based applications where you have lot of connections, or maybe more than 10,000 or 1 lakh of connection at one time, or millions of connection at one time. Might not be as good for such kind of applications, but it's good for the where the connections are less, more of a processing is done more. So for scenarios, these are more useful application. Okay, so vacuum and auto vacuum process. Okay, so so vacuum, we have already discussed that vacuum is such which is reclaims the storage occupied by the dead tuples. So the term of dead tuple, so dead tuple is a term which is used in Postgres for rows. Okay, so Postgres uses a term which is row in other databases generally is a tuple. Okay, tuple or tuple, whatever, how do you spell it? It's okay, how do you pronounce it? It's on you, upon you. So vacuum is the process which will clean up these tuples. Okay, whether all the rows that are deleted or updated. So deleted rows, and I've told you that when a delete happens, doesn't physically removes that row, it's still there, it is keeps there, it marks it deleted, this process starts up and deletes it. It runs every minute. So generally we need not to do it, actually we need not to do it, but sometimes a vacuum might be needed in some scenarios when auto vacuum might not reach that table,
Mm-hmm.
or you might have disabled auto vacuum. You might have disabled auto vacuum because vacuum is also a resource or
Consumes.
it's a resource consuming operation, right? So it consumes resource, so you don't want it to run all the time. Okay, you might keep it disabled on weekdays and might be running on night time when the load is less, or might be only on weekends kind of. So that, but you want a particular table to be vacuum, then you can run vacuum full or vacuum analyze with the table name, and then it will vacuum it. Okay, so vacuum full will just do vacuum full. What will do is simply reclaim the space, it reclaims the space. But vacuum full will log the entire table and will rewrite the table. Okay, rewrite the table. um I just telling you a term, just like what happens is actually in vacuum, assume there are 100 rows in a table, right? 100 rows in a table. Now
Mm-hmm.
you delete row number 5, delete row number 10, delete row number 25, delete row number 55, and delete row number 99. Kind of you delete 5 6 rows. Okay, but now vacuum will clean up these rows, but this free space are generally in between, right? They're generally in between. Even if a new insert comes in, it will not go and insert in between, go and insert in the last row only, after last row. Okay, this is how your storage structure are designed as well. This is not so performance, I would say, for betterment of performance, it doesn't happen in this way. It generally puts at the end of the table a new row. So in this way it will keep on working on. But if you do a vacuum full, it will rewrite the complete table. Okay, it will rewrite the complete table means it will clean up the complete table and will rewrite all those 100 rows into the new blocks. Okay, into the new blocks, so that all the free space that are created in between of the tables, so that is removed. Just like fragmentation, the term is known as fragmentation
One is highly
in IT.
recommendable. You go for
Yes.
a plain vacuum or vacuum full.
Vacuum full is locking the table. Vacuum
It's
full
a
is
risk.
locking the table. So when the table is locked, nobody can use it. If somebody has put a select statement, it will keep on waiting till the vacuum is not completed. Okay. So vacuum full is not a recommended approach to do it in the time of activity when the database is up and available and users are using it. Okay. It is not a recommended approach to do it. It is taking a lot of resources, and it is not a recommended approach to do it. Better to use a vacuum only, and then you can use vacuum full later on the weekends. Okay, or if you're very sure this table is not being used during this time, then go ahead and do it. Okay, so this is about vacuum full and plain vacuum. So vacuum processing can be automated by several auto vacuum worker processes as well, which wakes up every 1 minute. Okay, and there are 3 processes by default, which is defined by the parameter auto vacuum max works and auto vacuum nap time. Nap time is 1 minute. 1 minute it sleeps, then it starts again, and it will see which table need to be vacuumed. It will just see from the statistics table itself which table need to be vacuumed. Really some major things to be done, like 10 to 20% of rows are actually deleted, then we'll go and do vacuum. Okay, I think is there's calculation is somewhere around 10 to 20%, that also we can set actually, that also we can configure. Then only auto vacuum will go ahead and do it. Okay, so that is the how the, and there would be 3 parallel processing doing it. So is a resource consuming operation. By default it keeps on running, but if some user comes to you and say, okay, the database is working slow for me, or maybe a lot of users are connecting at that time slowly over, so then you can maybe for some time you can disable auto vacuum.
Can you
Okay,
go back? Can you go
it
back
will
to
at
the
least
previous slide? Oh,
it will at least
what is the 3 workers? And invokes three workers defined by auto vacuum max works means?
Three workers, three parallel processes.
I see. Three parallel processing. I
You
see.
can, yes, you can increase, you can make it one. By default it is three. By default this parameter is three. You can make it one, you can make it 10, you can make it 20, you can make it 100. To make it faster, you can make it as much as possible.
You
Okay,
mean
so you can
by default you're assigning three parallel sessions?
yes.
I see. Okay, thank you.
So this is about vacuum, vacuum full, vacuum full, vacuum normal, vacuum full. Then there is vacuum analyze, and then vacuum freeze. Freeze is kind of will freeze the table header. So for some time, it will not, auto vacuum will not happen to it. Auto vacuum will not check it for some time till any update happens to that particular table. Okay, so this will just saving some auto vacuum processing. You can freeze some of the tables where vacuum will not happen. Auto vacuum will not keep on checking. Not much used, I would say. Maybe
You
better
you mean
concentrate on
you mean you mean you can bypass vacuum? You can bypass few tables from vacuum, right?
right. So vacuum full, vacuum vacuum analyze verb rows is something which is giving you a print information. What all happened when you put a command vacuum verb rows, give a print information. Okay, we'll try all these commands as well. Okay,
Mhm.
so now these are the processes we already covered. Okay, these are the processes. Background writer, which is the process which is running from writing dirty pages which are there on the shared pool to a more persistent storage, which is writing to a more persistent storage
That's for
on
data
the
file, right?
yes, that data files. Check pointer is a trigger. Okay, so check pointer is a trigger that when this process starts, actually it triggers the background writer to write to the data files. It does not write anything, it's just a trigger. It's just a trigger. Once this when this when this is executed, when this checkpoint is executed, it will ping the background writer. Now it is a time to write. So check pointer is based on some particular time, some events. Okay, it based on the events. Okay, it has some events, it has some parameters, and in which it is get initiated. Auto vacuum we already discussed. They're invoked for vacuum process periodically. Background worker logical replication. So this process bg worker is logical replication. This is the process which is used for the replication. Okay, when you created a replicated database, val writer is writing from the val buffer to the val data. Statistics collector, it is used for collecting the statistics, okay, of your data. Log writer is writing your error messages into log file. Archiver is the process which is writing your val files to the archive val. Okay, so these are processes already we discussed.
Mhm.
Okay, so one thing which we discussed is the shared area. Okay, shared area we know is the shared buffer. Contains the shared buffer, it contains the val buffer. These are two things it contain. In addition to that, there is one more uh, process, one more area, which is the local area, primary area, local primary area, or we also known as the backend process area. Now this area is something which is what do you say, a different box for each session that is coming in. Okay, I generally put it 4 MB. Okay, I don't put it like just like you can say, or Postgres give it 4 MB to each session. Okay, Postgres gives 4 MB to each session. So what does it contains is, at the end when you return, when the query is returned, okay, any kind of sorting and hashing is required, is done in this area. Distinct operations, order by clauses, if some kind of even maintenance operations are using this
It's
area,
happening on
because
shared
each
buffer. Shared buffer.
no, this session is this area is completely different. This is not a part of your shared memory. Each session will have own its block of area. Whenever a session is connecting in, a session is connecting it, it is giving what it is connected to postmaster is giving it a server process, right? Now this server process or Postgres process or backend process is allocating one area which is known as the backend area or
Mhm.
local memory area. So this is local area is for each different session. Once the session is disconnected, you exit from from Postgres, you shut down your SQL developer or whatever you're using it, then it is automatically removed from your from the server itself. Okay, so this small area, which is by default of size of 4 MB, okay, this will be allocated for each session. Now what it is doing, your select star from EMP came from shared buffer, right? But if it is select star from EMP order by EMP number, it will just return you EMP table, but this order by clause will happen in this work area. Okay, if you're doing a vacuum operation from your session like not from auto vacuum, but you're doing a vacuum from your session, then it will do this vacuum also from this area. Okay, so all
What is the
kind of
size?
such
4 MB
4 MB is the by default size. You can increase this size.
buffer area, like memory within a session.
Yes. So by default it is 4 MB. So assume it is you have 100 sessions that are connecting to your database. So how much memory they are taking? They are taking 400 MB of memory. Okay. So total they are taking 400 MB of read, which each session will contain 4 MB. Okay.
Mhm.
Okay. If they need more memory, they will put the data into disk.
Mhm.
Okay,
Okay.
but into temp files, they put into temp files into the disk, but definitely it will create some performance issue. Then might be some would say that okay, increase your work memory. So there is one way you can increase at session level also. You can give particular session that is performing slow more work memory area, or what you can do, you can maybe increase the global level as well. Okay, so every session that is coming to your database, you might make it 8 MB or 6 MB, whatever you want to. Okay, or you, if you want that okay, all sessions are performing very well, this only this session is slow, so let us give more memory to this particular session. Okay, this is possible. So this is very good feature in this Postgres, because generally I found in other RDBMSs this memory is not dedicated to each session. This memory is also, this pool is dedicated, but you cannot give one particular session more memory, another session lesser memory, kind of another RD memory. Generally I'm not found, because the way I explored Oracle and SQL, so some areas the performance is better in Postgres is because the lot of development is, lot of concentration is done on this performance part.
Yeah, can you
Okay,
go back? Can you go back? So memory architecture located by each backend process for its own use. It is a temporary area work memory, maintenance work memory, temp buffers. Okay. And then can you go forward? Go to next session. Yeah. Memory after shared memory used
I'm
by.
coming to this session. Okay, this is a memory activity we already discussed. Okay, we already discussed which is the shared buffer area. I think that is
Yeah,
the
yeah,
plus
yeah,
sign.
yeah, yeah.
Is the shared area, the shared buffer area, val area, uh, val area shared buffer that is containing tables and indexes. Val is containing the val data. Earlier in, I think before version 9, it was known as xlog. Okay,
Mhm,
xlog stands for transaction log, but I
mhm,
think now they have changed it val data. But I am also very new to Postgres. I also started from version 9 only. I think
mhm,
some before 9 version, but now it is version 12 actually. Okay, so before 9 it was xlog, but now it is known as val area. Okay,
mhm.
val data, val mechanism. Now there is a commit log which is also keeping the state of all. This is also a small pool within it. It keeps a state of all transaction, that the transaction are in progress, committed or aborted. Okay, so it will keep a track of all the transactions that are happening in your database in this commit log currently. So
What
this
is
is
the
also
shared
part
buffer area? Shared buffer pool. You used some word is called pages. What is that?
of pages.
Shared buffer pool. Shared
And
buffer pool.
this is shared buffers, right? This
Mhm.
pages, this is shared buffers. Loaded pages kind of a blocks. Okay,
Uh,
pages kind of blocks. Okay, so there are some terms in Postgres which generally different from other databases. Like blocks is known as the pages, and rows is known as the tuples.
Tuples.
Okay,
Yeah.
and tables is known as the relations. Okay,
Mhm,
so maybe I'm writing it tables, but are generally in Postgres terms it is known as the relations.
mhm.
Okay. So there are some, in addition to this, there are some other areas, small areas for commit log, for contain. I think I told you there's a process array which is containing all the processes. So sub areas for each background processes. So everything, these process areas are also, these processes are also there in the that shared area itself. Okay, so there are sub areas for transaction processing as well. That what all transaction are there, just keeping a track of that transaction that are happening. This all is there in the instance. So if anything happens, if anything goes off, shared buffer will go off completely. Just like if the machine is down, shared buffer will go off. If any select any insert statement you have done or any update statement you have done, that update statement will be lost if commit is not occurred. If a commit is occurred, that is definitely saved. Not commit is occurred, then transaction is completed. Okay, if you do 10 inserts or maybe 100 inserts or 1000 inserts or 1 million inserts, but you don't do a commit, so that record will go off. All that 1 million inserts will go off if you don't do a commit, and if machine gets down. Okay, so so this transaction which will, where a commit has not occurred, that means the transaction is already running. Then these keep a track of all these transaction in the in this in this concurrency control or the commit log. Okay, once it is done, then it is it then this entry goes off from your this list. Okay.
What about auto commit? Is auto commit is implicitly default?
Yes, it is default.
Hmm.
Auto commit is default in pSQL, in PG admin as well. Just like in every GUI tool or in every, if you really want to do begin transaction, end transaction, then only you need to do commit. Otherwise, it's auto commit for each statement. Okay. So next is the file layout. Okay. So there are some configuration files. Okay. I think this is the, okay. These 3 4 slides are pending. Then maybe tomorrow we can do the what is it, installation.
Yeah.
So there are few files that are important in the configuration. PG version file, which will contain the version for the Postgres database. PG HBA file. PG HBA file, uh, which is very much important. Okay, so PG HBA file is something nobody can connect. Okay, nobody can connect to the Postgres database till the time you make an entry for that user into the Postgres. So Postgres can control, secure your Postgres in such a way that even if you know the host name, if you even if you know the port number of the postmaster, you know the database and username and password, you cannot go ahead and connect it. It's just a kind of a security list, or you can say, I'm also not that good in networking, but I think there is some security list that you can prepare, or just a firewall you can do, a kind of a firewall where you make some entries for some particular users only which can connect. Okay,
Hmm.
so you make an entry of particular users, particular host, that will only connect. Okay, so user has to provide all this kind of information, which user, which database it is connecting, which user and which host the connection is coming in. If this entry is made into this, then only a connection will be made. Okay, uh, identity is okay. Identity, maybe I think I will show you practically only. This will not be able to understand. PostgreSQL.conf. This is file is using to storing all the parameters of your databases. Just like the parameter I told you, what are the parameters? Like work memory is a parameter where you define what is the size of your work memory. PostgreSQL.auto.conf. Auto.conf. Some parameters are the parameters which can only be done. This PostgreSQL.conf is such a file which is containing the initial parameter when the cluster is created. Now, if you make any changes to this parameter, these changes will go to the PostgreSQL.auto.conf. Okay, because PostgreSQL.conf cannot be overwritten if you do any changes using alter system command. So these changes will go to the PostgreSQL.auto.conf. So whenever the cluster starts, it will first read the PostgreSQL.conf, and then it will run then it will read the PostgreSQL.auto.conf. Just like in PostgreSQL.conf, you have work memory parameter as 4 MB. Okay, but in auto.conf you put it as 8 MB. Okay, so it
Mhm.
will read 4 MB first, then it will read the auto.conf, and that this work memory is 8 MB. It will override that parameter 4 MB. Now it will definitely, the cluster will be 8 MB now. Okay.
Mhm.
Okay, postmaster.pid is the file which is containing the current process ID of the postmaster and data directory. Postmaster options a file recording the command line option that server was last started with. Okay, so file recording the command line option, whatever the commands you have fired on your Postgres, that all is containing, not through PL/SQL, on the Unix prompt. This history will go to the postmaster.options. I think practically when we'll see it, then we'll get to know it better.
Okay.
Okay. Okay. So how does a statement? Okay, let's come to. I think this statement processing might we can cover directly in tuning chapter. So what does the database cluster it? What does the database cluster stands for? So I think I've already told you in the first session as well. The term cluster is a collection of a database in Postgres terms. Okay, it does not means a group of database server. This is only one machine only. Cluster generally is a term used in IT, in technology wise, in IT, information technology or computer science, when you have
Setup.
multiple machines, shared storage, a kind of setup, right? But it's not about. This is not about multiple machines. The machine is one only. Host is one. You don't have such cluster facility right now available in Postgres, because you can compare Postgres as still not that advanced as compared to other RDBMS, which is paid versions of RDBMS. Okay, so
Mhm.
still on a single machine, you cannot share Postgres among different machines. Single machine, Postgres cluster containing multiple databases. It
Mhm.
comprises of a data directory which will contain all the databases, and these three default databases are created, which is known as template 0, template 1, and Postgres. Three databases are default by created in that cluster. Okay,
Mhm.
so template 0 and 1 are the template databases which you should not use it. You cannot connect, you cannot use it. You can connect, I think, but you should not use it.
Yes.
Template 0 and template 1 are the templates, and if you create a new database, then these copies of template 0 and template 1 are being copied to it. Okay, so there are two databases that are by default created. uh, Postgres is a database which is a read write database. You can use it. Postgres is database, you can use it, but generally people create their own database with your own name and then start using it, and they can drop this Postgres database as well. Okay, so so what you do, you create, you just like assume you want to have 10 users always in your database. You
Mhm.
want to have 10 users, and you want to have 10 tables in each 10 schemas, and you want to create copies of these database. So better do all this into template one, and whenever you're creating this database, you use this database to create a new database as a template. Okay, so you
Mhm.
can set some templates. So that's the reason two templates are there for you to create different types of databases. But this is not suggested to have multiple databases. Only create a database when it is really needed. I think I already discussed it is difficult to join databases across.
Yes.
Okay, so if you want to have something really separate entity altogether, then create a different database, just like a department of finance and HR or marketing, where joining will not happens, but marketing and sales are joining can happen. So better to create a database with the name of maybe I don't know, any name with two schemas, one for marketing and one for sales. And because you might be knowing that lot of joins would happen for marketing and sales. Okay, so just like create a technology database in which there can be a service operation team and maybe a delivery team and maybe some other team. Maybe I'm just talking about internal database for any organization. Okay, then because lot of joining would happen between delivery and operations team, and lot of people might move, or lot of things you might to join to give some results or some queries, right? So if you want to join, then better to create different schemas within a database. Not don't create different databases. Okay, for every different entity, better to create different schemas within same database. Create only one database itself. Okay, and create different schemas.
Mhm.
Okay, but as database is a different entity whenever you're taking a backup. Okay, so generally, and whenever it is completely a different entity, you can create a different cluster altogether. Okay, because
Yes.
a different cluster altogether, then all your memory allocation, everything would be different. Just like this particular server is of dev database, and you cannot club one dev and one production and one test into one database, into one cluster. Not suggested, because for dev and test database you need not to have large shared memory. Okay, very large shared memory. And if you create so large shared memory and everything, then I think then a lot of data would be there for dev and test in your shared buffers, and that is disturbing the performance of the production. Okay, so better if you have production database, then create one cluster for dedicated one production. Okay, give the amount of memory you want to allocate it. And if you want to have uh, you can club different dev databases into one, or different test database, if you're not worrying about the performance, because each database will interfere each other in should not interfere, I would say, in but in performance wise, right? In performance wise, because everybody is sharing each set of processes, everybody is sharing each shared services. Okay, so this is all about the cluster.
Mm-hmm.
So how about the architecture? The storage architecture. Architecture is one file per table, one file per index. Okay, so one file per table and one file per index. Every time you create a table, a file is created. Every time you create an index, a file is created. Each file size is 1 GB, and then it creates one more file if it is filled. Additional files are also used to hold auxiliary information. Auxiliary information that I am also telling you. There is two more files. Okay, at the end we will discuss this. Okay, each file name is number pg.class.relative file node. uh, so pg.class, so each file name is a number. Okay, so each file name is a number. So if you have emp table, school table, it will give it a number. These numbers you can find it out in a dictionary table known as pg underscore class. Okay, so in the pg underscore class you can get the number. Okay, you can get the number of each file
What is the
of each.
auxiliary information? What is that?
Auxiliary information is kind of a information which is the visibility map. And this is in the last slides, actually. I will just tell you when this comes
Okay,
out.
okay, yeah,
Okay.
okay, go ahead. We'll discuss in the last.
Okay, so PostgreSQL support table spaces. So table space is nothing but a directory or a logical division of files. So by default, there is one table space which is containing all the data. But after some time, all these files would be difficult to be there on one disk, right? On one disk. So you might be thinking after some time to maybe relocate these files or create one more directory. Okay, that would be better to create one more directory, so that you might be putting on different mount point. Okay, so as the things are increasing, so you can create one more directory and make a table space. So table space is a directory or a folder, and then you can put data files into it. Okay, so by default, whenever you're creating a table, you can define the default table space for it, or for a schema also you can define a default table space for it. At the database level also you can define a tables this table space as well.
Table space means you can
Okay,
track the size of the file, something. Tables,
table space is a collection of data files.
collection of data files. I see.
Okay, okay, is a logical division. By default it is only one. By default it is only one. But assume that this definitely this is on particular mount point, right? That mount point can get full. So better to have multiple table spaces, so that you can create one more table space and put into a different mount point, then start putting all your databases schemas into that particular, all newly created. You can not move it, might be, but you can all move it, all you can make default table space for all newly created databases.
Okay, thank you.
Okay, okay, so then is the this is the directory layout. This is the directory layout for Postgres. Global base directory, PG tablespace, PGX log, PG log, status directories, configuration files, and postmaster info files. Okay,
Mhm.
this is the which is containing the database, cluster wide database objects is the global directory. So under then in the data directory, these are files. So for us important is this write ahead log, pg underscore x log. This is containing the val files. This is containing a link to the table space. This table space can exist anywhere on that machine, but in this data directory, this link would be created. A soft link would be created.
Mm,
So this base directory is containing the database. Okay, these database internally will contain different directories for different data files.
mhm,
PG log will contain a error log files, and there are other configuration files as well in this status directory. And this is also configuration which we discussed: PostgreSQL.conf, pghp.conf, identity, and uh, postmaster informational files. So all this is the kind of a directory layout structure. I
mhm.
think this slide is repeated. Okay, so this is the way you can create a table space. You can put a tables, create tables space just for a demo purpose. We'll do it practically once it is installed. You can create a table space, T1 location. You can put a location for it, and whenever you're creating a new table, you might be knowing a create table command. Okay, whenever you're creating now a new table, you can put a table space name in front of that, so that this table goes into this directory. Okay, so
Oh, you mean when you create a table, the table should be located on so and so file directory, right?
yes. Okay, not into a by default directory. So in this way you can set these maybe better is this we put a default table space parameter at a schema level or at a database level as well. So
Yeah,
table space concept is a directory kind of a concept, is
yeah.
a kind of a directory, if you can say it. Okay, so these are the default
Storage
directories which is
directory. Storage directory.
storage directory. So these are the default directory which is already there: PG underscore global and PG underscore default. These two table spaces are already there, where PG underscore default is there in the base directory. Okay, these base directory, this is containing all these what we say, all the databases data, all the data files for each database. Now PG underscore global is containing the dictionary files.
Mhm.
Okay, the dictionary file system catalog files, just like the data about the data, and the control files, all other internal files. Okay, these all will contain under PG underscore global, and PG underscore default containing the data files, and PG underscore global containing the catalog files. Okay, just I think this thing should need to be remembered: PG global containing the catalog files or dictionary files. Okay, known as the catalog in Postgres, but you can also call it dictionary also. Okay, dictionary means the data about the data, the structure of the table, the location of indexes, size of the table, permissions, authorization, roles, privileges, such things. Okay, PG default is containing tables and indexes, sequence, such kind of things is contained in the PG underscore default. So this is the command slash DB plus, where you can see
Is
all
there
the
any
table.
is there any client tool is available, or we have to log in into Unix system and then do the query?
Yeah, yeah. The client PSQL is available. PSQL.
PSQL or SQL Workbench, we can use these client
Yes,
tools,
yes.
right?
Right.
I see. So you don't need to connect with the Linux and Linux system to all these things.
No. You will not put. You go to the Linux system, then you say psql, then you go to the psql prompt, and then you can type the queries, whatever you want to.
Whatever we are doing, whatever the queries are running in SQL Workbench, you can do the same thing.
Yes. Then there is one PG admin tool as well.
Mhm. Okay. Yeah. Next. Yeah. Go ahead.
Okay, so this is about table spaces. Now, how the table is stored in the database? Now, table is stored in the form of pages, okay, or blocks. Okay, so the default size of the block is 8 KB. Okay, and these blocks are being numbered from 0. Okay, so this is 0. So every time when a table is being created, an 8 KB block is being allocated to it. Okay, it doesn't go to 1 GB at first instant. Now when 8 KB is full, it allocate one more block 8 KB, and keep on incrementing from 8 KB to 8 KB, 8 KB, 8 KB. Okay,
Mhm.
so the term uses page. in Postgres, not blocks. Okay, whenever you're reading it or whenever you're checking the dictionary tables, it'll use the term page. Actually, as a DBA, we don't worry. For our knowledge sake, have added this slide that we should know how does it internally behave. So as a DBA, we don't require it for it. Such internals are not required while administration jobs, but at least we should know how does it progress
Okay,
internally. It is
very
a
helpful.
block.
Yeah,
Yeah,
very helpful.
sometimes it helps. Yeah, sometimes it helps. Yes. So this is the way it is designed. So in this block also, the each block will have an header. Okay, each block or each block, or you can say each
Each block has a
or
header.
page as a header as well. And these header is there in the beginning, which is 24 byte long, which will containing the rows, which are being the information about the rows that are contained in that rows or tuples, a pointer which is there, which is contained in that particular block. Okay, or page. So that tuple identifier is there, which is will identify that particular tuple. So TID is the term which is consists, which is the address of each row or each tuple. So this TID is equivalent to the block number of the page, okay, that contains the tuple, and offset number of that line pointer, okay, for that particular block. So this TID is the identifier for that particular tuple, okay. So this TID information is stored in the dictionary tables. So this is the way it is able to identify each table, where the table is, which block it is. Okay, if somebody puts a query, select star from this, then how it identifies where it is. It will identify from all these dictionary informations. So this table's information, this tuple identifier is contain the block number and the offset number of the line pointer. This might be more person who is more on the hardware side might be knowing more these terms about line pointer and offset number. This is just for a knowledge sake. How does it works? So one header information, one header data is there, which is allocated in the beginning of blocks, that is containing all the TIDs, all the tuples that is there in the uh, particular uh, block. Okay, so there is one more, free space map and visibility map. Now these are the auxiliary information for each block or each table, each file. There is FSM and VM. Now this FSM VM is just showing you which it keeps a track of available space in each relation. Okay, so now whenever any request comes in to insert the data, where it should insert the data, which block it should insert the data, which block is empty, which page is empty, this all this information will be contained in the FSM.
Mm-hmm.
Okay, so these each heap and index relation has a FSM and VM to keep a track of available space in the relation. The purpose of the free space is to quickly locate a page with enough free space to hold a tuple to be stored. It is named after the file node number of the relation. So what is the name of this file is, whatever the file number is, like 12345 underscore FSM. Okay, there is a link if you want to read more about it. There's a link I have specified in this slide. Once you will get this slide, you can go to this link as well, and you can read more about it if you want to go to more internals for this Postgres.
So it takes time to understand these files purpose and other thing. Yeah.
Right. But I think this is the only thing we need is to know this is that what is FSM is. It is containing the free space for each relation. Visibility map is keeping the track of which pages contain only tuples that are visible to all active transactions. Okay, so just kind of an information which is needed in case which tuples are getting utilized right now, which tuples are getting utilized right now, in case there is some blocking kind of information, or in case of index scans need to be happen. So this information is used by the index only queries. Okay, for the index queries for such information are known as is being tracked in the visibility map. Okay, so this contains visibility map is the term which keeps the information of row IDs that are currently being used in any of the active transactions actually.
Mm-hmm.
Okay, so these are the two extra files that are being contained in the that particular base folder. One is the table, and addition to the table file, which is containing the data. There is FSM file, which is containing the free pages, which has the enough data for the free pages to put some data. And there is one more, which is the VM, visibility map, that is containing the row IDs or the tuple IDs of the rows that are currently being used in any of the active transactions.
Mhm.
Okay, so this is the internal architecture. Okay, this is the I was sharing these slides as well, and if you want to go through it once more, you can go through the recordings. Okay, so this is the internal architecture, and tomorrow we can start with the installation, and I would be showing you all the configuration files as well, which all we covered in today's chapter.
Yeah, yeah. So let's
Okay,
start
thanks.
tomorrow. Let's start the practical on tomorrow onwards.
Yep. Okay, prepare a machine. Okay, prepare a machine to Linux machine, maybe SUSE Linux, Red
No,
Hat
no,
Linux,
no, no.
anything you're
I have
looking
an
for.
AWS account. We can launch an instance on AWS.
Right. Yeah, that would be better. Okay, okay. Thanks. Bye.
Yeah, we shall meet at the same time tomorrow. Yeah, thank you. Thank you,
Yeah,
Arnav.
thanks. Bye.
Bye.